Good evening, everyone. Kamlesh, can you mute yourself? Good evening, everyone. Am I audible? Can anyone respond?
Yeah, it's audible. Go ahead.
Yeah, I hope you have all watched the lecture videos. Do you have any doubts? First, we'll start from that, and then I'll go into the thing what I wanted to discuss. Did you face any issue with any topic? Yeah, like you can unmute yourself and you can speak. No problem. No doubts.
Hi. I
Yeah,
actually had a doubt.
okay.
Like we can ask doubts related to week two, the robot building thing, right?
Robot building, no, not robot building, first week or third week. Robot building can be discussed by some other instructor.
Okay,
You
okay,
can
fine.
ask related to week one and week three.
Okay.
Hmm. Do you have any? So shall I proceed with the thing? Is my screen visible? So in the week three, main topics like envelope is been discussed. It is like they have approximated. If you want to approximate something, like if we can anyone tell what is the value of pi? It will be 3.14 and so on, right? So it is not it is a approximate value, but not 3.14 is not the exact value, na? And if we take Taylor series, like Taylor series helps us to make approximations. So if we take what Taylor series tells us, if there is a function f of x, like if we want to converge to a point, will be to a point A, it can be written as, it can be approximated by using this formula f of a by 0 factorial, and we'll be adding to that x minus a, and we'll be differentiating the function double differentiate. First we'll be differentiating with the one time and dividing with the 1 factorial plus x minus a whole square, and again here we'll be doing double differentiation by 2 factorial and so on. In this way, like even if we take e power x exponential function, this can be approximated by 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. By using Taylor series, even many other things can be done, like even sine function, cosine, tan, everything can we can approximate these functions. Clear? And next is resistor. So like if you take a phone, like if you use for lot of time, like it gets heated, right? What is the reason behind that? What could be the reason why it is heating? Are you there? Are you there, students?
Yes, ma'am.
Okay,
Ma'am, so to my knowledge, as current when it flows, it produces heat. That's the reason.
yeah, correct. So it will be having uh in the mobile we will be having the battery. So this battery will be used, and because of that charge, like what you told, like it gets heated up. Even our laptops also get heated up. And if we see like if we take the heater, it will be having the coil. So so like when the current flows through the heater, like if we see heater, so if we when we immerse in some water, so this is a coil which is made up of inside it will be having the wire. So when the current flows through it and power, I mean power all having certain power rating, when the current flows through it, when it is connected to a certain source like voltage source, it will be dissipating the heat. So which helps the water to heat. Did you get my point? What I'm conveying?
Yes, ma'am.
So like so in this way, like even the kettles all in these phenomena, it's all because of resistance. So what is mean by resistance? It is opposition to the flow. In the electric in coming to the electrical related, resistance to the flow of electrons is called resistance. It is the opposition to the flow of electrons. That is the reason it is getting dissipated and power is getting used in such a way. So like so power can be written as energy by time. And another formula is power can be written as V into I, voltage into current. And according to the Ohm's law, like what is Ohm's law? V is directly proportional to I. So based on that, V is equal to IR. So if we substitute in this, a power can be V square by R, or it can be power is equal to I square R. If we substitute this, if I substitute in place of V, that IR will be getting I square R. Like in the similar way, we can do when we substitute the I value in this formula, we'll be getting as V square by R. So like energy. So energy is, what is energy from this formula? It is power into time. So energy in terms of voltage and current is voltage into current into time. But like energy can be, like since it is power into time, we can do V square by R into time, or it can be I square RT. So energy can be any form, like light energy, heat energy, uh, like many forms of energies are there. And one more thing, like if there is a charge, if we take some electron, so around it there will be field around it, electrical field. If we take a charge, if we take a charge Q, there will be some field generated. There will be some field present across that. That field is known as electrical field. That is a so electrical field is a region around the charged particle. Or if we take magnetic, if we take magnet, if we keep far some iron particles away from it, it won't get attracted. But if we get that iron fillings near to the magnetic field, it gets attracted. So if we get something into the field, it energy will be uh, I mean some force will be present on that particle to attract that. Yes, Kamlesh. You have raised the hand. Yes, Kamlesh, should you do you have any doubt? Mm. Do you have any doubt, Kamlesh? So like it is electric field is represented by this symbol because it has some direction. So it is equal to force divided by charge. So if there is some particle, the force applied on the particle by this charge is known as electric field. And I'll be discussing the relationship between voltage, work, as well as charge. The relationship is voltage is equal to work by charge. So like you keep these formulas in mind so that like these formulas will help you in solving the problems. And like there is some derivation explained in the lecture in the third lecture of week 3. That is like can if there is a conductor which is connected to a voltage source. So what is a current? I would like to ask before going into that. Current is charge per unit time, right? So current is charge per unit time, right? So how can we calculate the charge present in a conductor? So electric field will be in this direction and a flow of electrons will be in this opposite to the direction of the electric field. And let's take the length of this conductor as L, width as W, okay, this width as W, and it is taken, let's take in a small area, like in a small volume of dx. So what will be the volume? Volume is equal to length into breadth into height. So L into W into dx. So how can we calculate the charge present in that conductor? So we know the volume in that area, in that volume, there will be some electrons present in that. So we have to know the density of electrons present in that region. So let N be the number of electrons present in unit volume. Then charge is equal to N into length into width into dx and charge of one electron. So this is number of electrons present in that volume. And how can you get the charge? By multiplying with the E. So where E is 1.6 into 10 to the power of minus 19 coulombs. And here N is number of electrons per unit volume. Are you getting?
Yes, ma'am.
So like if we divide by T on both sides, okay, I'll be writing in the next line. So I'm dividing by T. And length into width can be written as cross-sectional area, right? A into and dx by dt. Dx means distance by time. Distance by time, what does it measure? Speed or velocity, right? So we'll be taking dx by dt as v d. So here vd is drift velocity into e. So I is equal to n into a into vd into e. Hope this derivation is clear to you. So shall we solve some problems?
Yes, ma'am.
Yeah. Like if you have any doubt, you can free to interrupt in between. You can ask me if you have any doubts. So the question is, a metallic wire, it carries a current of 2 amperes. And which is having the drift velocity of 5 into 10 to the power of minus 4 meter per second. And if the radius of the wire is it is increased by a factor of 3. While keeping the, so like in this case, electric field remains constant. So why? Keeping the electric field unchanged. So we have to find the new current through the wire. Find the new current through the wire. How can we solve this? What approach will you be following? So you try to solve and let me know. I'll give you 2 minutes of time. And you can tell me the approach what you are following in this in order to find the new current.
Ma'am, is the new current 18 ampere?
Sorry?
Is the new current 18 ampere?
Is the new current?
Like, is the value 18 ampere?
We have to find the value. Okay, you are telling. Oh, yeah, it is 18 ampere. Correct. It is 18 ampere. Can you tell me the approach?
So yeah, like here the cross-sectional area of the circular wire will be pi r square. So
Yeah,
and we need to use that formula I equals to NAVD into E. So
good.
then we need to replace all the values, like if we take R2 equals to 3R1 and
Hmm.
all the rest of the values are same, and if we take out the ratios of I2 to I1, then
Hmm.
from there we will get this value.
Yeah, correct. Good.
Actually get the ratio as 9, so I2 will be
Yeah,
9,
yeah, yeah.
I1 like that.
Yeah, correct. Absolutely correct. So I in like in the previous slide I have told no I is equal to NA VDE. So like here A can be written as like here they asked in terms of radius. So area of cross section is equal to pi r square VD into E. So these all things are constant. So what factor is changing? Radius is changing now. So I is directly proportional to r square. So here we can write as I1 by I2 by I1 is equal to R2 square by R1 square. And R2 is increased by factor of 3. So it is 3 times the R1. That's how we'll be getting. So if we do the square, here it will be 9 R1 square by R1 square. So I2 will be 9 times I1. So I1 is 2 amperes. So then new current will be 18. Hope everyone got clarity. Any doubts?
Yes, ma'am.
Okay. So we'll go to the next problem. Question. So an electric bulb dissipates it dissipates the power P naught when connected to voltage source V. If the bulb is connected to the source of voltage which is 3 times. So if the bulb is connected to a voltage source which is 3V, and here we are assuming resistance remains the same. Assuming resistance remains same. Find the new power dissipated. Which is, I mean, how many times of P naught the new power will be dissipated? We have to calculate.
Ma'am, 9 times.
9 times, yeah.
Correct. Good. So here, how did you do?
Ma'am, power is
Power is
equal to V square by R. R is constant, so you can equate
Huh.
it.
So power is good. So here, power is directly proportional to V square, right?
Yes.
Since R is constant. So P2 by P1 is equal to V2 square by V1 square. So here 3V whole square. So which will be resulting as 9. So here P1 is P naught. So P2 will be 9 times P naught. So good. So hope everyone is clear with this. Can I go to next?
Yes, ma'am.
yes, ma'am.
So here like we'll be taking an electric heater. So an electric heater is, it is connected to a DC source. DC voltage source, and it dissipates power P. If the supply voltage is increased by 20%, while the heater resistance remain constant. So we have to find the new power dissipated. what will be the new power dissipated? How will you be doing this?
Ma'am, the answer is 36 by 25 times the power.
Good, correct,
Ma'am,
absolutely.
so what I did is, since it is increased by 20%, I took
Mhm.
120 by 100 into V. So it is 6 by 5 V, and then
Yeah,
directly proportional, so square it.
yeah, good, good. So that is the approach. Thank you for telling the detailed approach, Kavin.
Right.
So here the hint is like in general, like whatever problem you take, you have to see what are the required things and what are the leftover. And we have to see what formula we need to use. This is the simple technique everywhere, like whatever, like anywhere, like if you want to do, just see what are the required details they have given, what are the missing things, and what formula, which formula is related to that. Just substitute and we can get the final answer. So here voltage, what they have given, the new voltage is increased by 20%. So, so V2 will be V plus V times 20%. So if we calculate, what will be the result? So here we'll be getting 1 by 5, right? So as a result, it will be 6V by 5 we will be getting. So in the previous slide, I have told like ratios. We'll be using that same technique. P2 by P1 is equal to V2 square by V1 square. So which will be 6 by 5V whole square by V square. So it will be, as a result, if we calculate, it will be 36 by 25 times that. So P2 will be 36 by 25 into P1. So which will be, if we calculate 36 by 25, we'll be getting us some 1.44. So this is the answer. Clear, students?
Yes, ma'am.
So here, for a charger, it is rated with 24 watts. And it is used to charge a battery for 30 minutes. Assuming ideal conditions, the total energy supplied to the battery during this time is dash R. So how to do this?
Ma'am,
So
12 watt.
yeah, correct.
Yes, ma'am. Power is equal to energy by time that I used, and time I converted to 0.5 hours.
Yeah, correct. So, and like whatever, like units also matter, like wherever you see. Like sometimes we'll be confused with the units. So we have to check. So what you have told is correct, Kavin. So they have given us, we have to find the energy. So energy is equal to power into time. So power is 24 watts. And we want the answer in watt hour. But here we are having like 30 minutes. So 30 by 60 we are converting into hour. So 24 into 1 by 2 it will be 12 watt hour. So this is the answer. So like you have to check the units also. Any doubts?
No, ma'am.
Okay. Do you have any doubts in the graded assignment or practice assignment? I mean, do you have any issue with that?
As of now, no, ma'am.
Okay, did you try to solve?
Yes, ma'am, I've completed it.
Okay, did you face any issues or is it fine?
No, ma'am, it's okay.
Shall we solve few more problems then?
Yes, ma'am.
Okay, just a second. Okay. So now a heater coil A, it takes 20 minutes to heat a certain quantity of water. And temperature increases by like when so temperature of the water increases to 10 degrees. Sorry, by 10 degrees. It increases by 10 degrees centigrade. Another coil D takes 10 minutes for the same rise of temperature. So, how long, and I want answer in minutes, would it take to achieve the same temperature? if we keep both the coils immersed in the water. If both the coils are immersed in water together. So, how will you be doing this? Are you trying, students? Hello.
No, ma'am, I don't know how to solve.
Okay, one hint I'll give. Like heat is a form of energy. It heat heat is a form of energy, and you would have known like heat is equal to ms delta T. Like this is a hint I would like to give. Like where m is a mass, this is a specific heat of the material. Here we are considering as water. Delta T is a change in temperature.
Okay.
This is a hint. Are you trying or should I solve?
Ma'am, you explain it, ma'am.
Okay. So you are clear with this point, right?
Yes, ma'am.
H is equal to ms delta T. So like power is equal to energy by time, right? And it can be like energy, as I told, energy can be any form. It is heat energy by time, right?
Yes, ma'am.
So PA will be heat energy, and the temperature is also same, right? We are rising to the 10 degrees centigrade. And the time taking for the first coil is 20 minutes. Are you clear with this part?
Yes, ma'am.
And how about power dissipated by the coil B?
H by 10.
Correct. So, what they have asked us here, we have to find it how long it take. So, we are keeping two coils in the same water now. So, what will be the total power now? it will be PA plus
Plus PB.
PB. So it will be H by 20 plus H by 10. So as a result, we'll be getting 3H by 20. So, what is a initial, power is equal to heat by time, right? So we have to find the time. So power is equal to heat by time. And here we are rising to the same temperature. Correct. I mean, we are rising by 10 degrees in all the cases. In the first case, like when we keep the coil A, it is rising to the 10 degrees. Like in the case to rise at 10 degrees centigrade, it is taking 10 minutes of time. In the third case, what will be the duration of time when it rises to 10 degrees centigrade? So here we'll be taking it as constant, right? So time is equal to H by, energy, heat energy by power. So what is so here we'll be taking the total. So it will be 3H by 20. So 20 by 3 will be getting as an answer.
Clear, ma'am.
Hope you got some clarity. Oh, sorry, it is a time, right? So we'll be getting as 6.67 minutes. It takes this long when we immerse two coils together. Everyone clear with this?
Yes, ma'am.
Yes, ma'am.
Any more doubts? This is what I thought of discussing today. I hope most of the things I have covered, similar kind of problems, or it's all most of the tricky problems I covered. If I have any doubts, you can ask. Thank you.
Thank you, ma'am.
Okay. If you have doubts, you can stay back. Yeah, if you have any doubts, you can ask me, or else you can leave. Hello.
Excuse me, ma'am.
Yeah.
Regarding subjects, I have no doubts, ma'am, but I have a clarification regarding my hands-on activity. Is it okay to clarify it here?
Related to robot projects, is it?
Yes, ma'am. Yes, ma'am.
Like you can contact
No, ma'am.
Abdul.
It's not about building, ma'am. Actually, I filled the form saying that I'm not interested, but I am actually wanting to do it now. So in the graded assignment, I've updated it to interested, ma'am. So is that okay?
I will let you know. Like, did you mail support team?
No, ma'am.
Like, uh, can you let them know? Like,
Okay,
you
ma'am.
can just inform them.
Okay, ma'am. But in the
Mhm.
graded assignment too, I've changed it to interested, ma'am. So is that okay?
I think it's okay, but once I'll talk to the team and the let you know in the next session. Is that fine?
Yes, ma'am. Okay, ma'am.
Okay.
Thank you, ma'am.
Shravani, right? Okay. Thank you.